Okay guys, we're continuing lesson 5-3 on page 85. You were supposed to answer these 4 questions, okay? Number 4, what does the notation g of h of t represent, and what is another way to write it? Well, another way to write it would be to write it with parentheses, like this. So you should have said something about that. And it represents the composition of functions g of t and h of t, with h as the inner function and g as the outer function. Okay, and number 5, explain how fog f of g of x is different from f times g of x. So you should have said something about fog of x being composition because of the open dot, and the closed dot here, that's a multiplication problem. So you should have said that one was multiplication. Sorry, I'm at home filming this, so you have to hear my dogs running around in the background. And the number 6 was it gave you 2 functions, p of t and q of t, and then write the equation. So write the equation for the composition. So this should have gone something like p of q of t, and that means you're taking function q and plugging it into p. So you're really finding p of t plus 3. So we're going to take t plus 3 and we're going to plug it into into function p there. So using parentheses, we're going to take out the t and replace it with the t plus 3. And your explanation would be, I plugged in a t plus 3, I replaced the t with t plus 3, and then to simplify your answer, notice the square is still there. Since this was t squared, okay, since it was t squared, I have to square that t plus 3. And I'm going to change that t to a cursive t, so it doesn't look like a plus sign. So t plus 3, since it's being squared, you have to write it twice, and then distribute. That's going to become t times t, which is t squared, t times 3, which is 3t, and then 3 times t, which is 3t, and then 3 times 3, which is 9. Bring down the plus 4, combine those like terms, 3t plus 3t, so you have t squared plus 6t, and then 9 plus 4, which is 13. So the answer here for p of q of t is t squared plus 6t plus 13. Okay, and so that's, just a little explanation for the answers for those problems. So for example 7 through 11, we're going to use these 3 functions. So here's some examples for you. So we've got f, g, and h of x. First, we're going to find g of f of 2. So this means to plug 2 into f first. So f of 2 is going to be 2 squared, which is 4. Then we're going to take the 4 that we got and plug it into g. So that's going to be g of 4 equals 2 times 4 minus 1. So that'll be 8 minus 1, which is 7. So our answer would be 7. Okay, on B, find f of g of 2. So we're going to find g of 2 first. And we're going to get 2 times 2 minus 1, which is 4 minus 1, which is 3. Then we're going to find f of 3. Take that 3 and plug it into f. F of 3 would be 3 squared, which is 9. So our answer for this one is 9. Start with the inner function and work your way out. So that was evaluating, by the way. Now we're actually going to write the composite functions on number 8 here. We're actually going to have an equation. So the first one is g of f of x. So we're going to take f of x and plug it into g. That's what's going to happen here. So that's going to be g of x squared, which will be 2. And where the x used to be, now it's going to become x squared minus 1. That's really all I have to do. I just take the x squared and plug it into g. Alright, on b, we've got f of g of x. So now I'm taking function g and plugging it into function f. So that means this whole thing, the 2x minus 1, is going to replace the x in function f. So I'm finding f of 2x minus 1 here. So that's going to become 2x minus 1 squared. And to simplify this, 2x minus 1 times 2x minus 1. 2x times 2x is 4x squared. 2x times 1, negative 2x. And then negative 1 times 2, so that's a negative 2x. And then negative 1 times negative 1 is positive 1. We simplify that guy out and we get 4x squared minus 4x plus 1. Okay, and that is the answer for B. And this was the answer for 1, 2x squared minus 1. Number 9, verify that you compose. Okay, so number 9, it says to verify that you compose g and f correctly by evaluating g of f of 2 and f of g of 2 using the functions you wrote in item 8. So we're going to be using these functions right here that we found. To make sure we did it correctly, we're going to find g of f of 2 again, okay? And we should get 7, because that's what we got when we did it up here, when we did them separately. So up here I did them separately. Down here on 9, I'm going to use the composite function to double check these answers. So g of f of 2, which is this guy right here, this is g of f of 2, g of f of x, and I'm going to plug 2 into it. So I'm going to do 2 times 2 squared minus 1. 2 squared is 4, so I have 2 times 4 minus 1. 2 times 4 is 8 minus 1, and we get 7. So this was the same answer as up above. Okay, so now when I do f of g of 2, I should get 9 again. I should get 9 again. Except now I'm using the composite function to do it. So I'm going to plug in 2 into that thing. So 4 times 2 squared minus 4 times 2 plus 1. Okay, order of operations says we're going to do the exponent first. So this is going to be 4 times 4. And then this one is 4 times 2, so that's a minus 8 plus 1. 4 times 4 is 16 minus 8 plus 1. And then just go left to right. 16 minus 8 is 8 plus 1 is 9. So f of g of 2 gives us 9, which is the same thing that we got up here. Okay? So there are 2 ways to do it. You can plug them in separately, or you can write the function first and then plug in the number. The next page, number 10 here, evaluate h of g of 3. And so these are the same functions that I had on the previous page. I just copied them down here. So we're going to find g of 3 first, start with the inner function. G of 3 equals 2 times 3 minus 1, so 6 minus 1 is 5. That's g of 3. Then we're going to take the 5 that we just found, and we're going to plug that 5 into function h. So h of 5 is going to be 4 times 5 minus 3. 4 times 5 is 20, minus 3. So our final answer here is 17. Now we're going to write the composition. Okay, we're actually going to do the function composition. Hog of x is the same thing as h of g of x. Okay, so I'm going to take function h, and I'm going to plug in g of x, which is the 2x minus 1. So it's going to be 4 times minus 3, and in our blank, I took out the x, and I'm replacing it with 2x minus 1. And simplify, 4 times 2x is 8x. 4 times negative 1 is negative 4. Bring down the minus 3. And then finally we're going to get 8x minus 7 is our answer. And then now we're going to evaluate g of 2. So we're using function g twice here. First I'm going to plug 2 into g, and then I'm going to get an answer, and then I'm going to plug that answer into g again. So g of 2 is going to be 2 times 2 minus 1. 2 times 2 is 4, minus 1 is 3. So g of 2 equals 3. Then I'm going to take that 3 and plug it into g again. So that's going to become g of 3, which is 2 times 3 minus 1, so 6 minus 1, which gives us 5. G of 3 equals 5. So g of 2 equals 5. And then we're going to write the composition. I'm going to take g and plug it into g. So function g of x was 2x minus 1, right? So gog of x is really g of x. So I'm taking function g and I'm plugging g into g. So it's g of 2x minus 1. And that's going to give us 2 times something. That something is going to be 2x minus 1. So I removed the x and I replaced it with 2x minus 1. So that's going to be 4x minus 2 minus 1, so 4x minus 3. So gog of x equals 4x minus 3. Okay, so you're going to answer these questions. Explain how we found the composition for gog of x. So it's talking about this thing right here. Explain the process that I went through to get that. And then number 13, given function p of n and q of n, for what value of n makes our composition equal 8? So you have to do the composition p of q of n, set it equal to 8, and then solve it. After you submit that, go to the next assignment and submit the practice. The practice is page 86, 14 through 18.